This video is being brought to you by Science DIBS, where drills increase basic skills. This video is about lactate dehydrogenase. Lactate is produced in the muscle, as illustrated here, after the production of pyruvate through the process called glycolysis. That pyruvate production will allow, in under anaerobic conditions, for lactate to be formed. By anaerobic conditions, we're talking about a lack of oxygen. The enzyme involved in this process is lactate dehydrogenase, and it is an oxidoreductase enzyme that will use pyruvate, which is an oxidized form, and produce lactate, which is the reduced form. In order to do this, it needs a coenzyme. So it uses NADH, which is the reduced form, which will produce NAD+, the oxidized form, in addition to producing lactate, which again is the reduced form. That lactate that's produced from pyruvate can pass through the blood to the liver, and it actually can be utilized to produce pyruvate, and that pyruvate can go on and be involved in the process of gluconeogenesis. Again, lactate is the reduced form, and pyruvate is the oxidized form. Lactate dehydrogenase is the enzyme involved in both processes, what's happening in the muscle and the liver. That should let you know that it is a reversible enzyme. And so let's look at that a little bit further. There's a double arrow here showing that lactate is able to go to pyruvate. So it's taking that reduced form of lactate, giving you pyruvate, right? So you have the hydroxyl group that will get oxidized and give you this carbonyl group that is on pyruvate. In addition, that lactate, which is reduced here, going to pyruvate. Pyruvate will produce that oxidized form and give you that NADH. So that was already mentioned in the previous slide. Again, it's reversible. So pyruvate, the oxidized form, can go back and give you lactate, the reduced form, and also that coenzyme NAD+, which is the oxidized form. So lactate dehydrogenase oxidizes lactate to pyruvate, but it is reversible. It can go pyruvate to lactate as well. So I mentioned that it's anaerobic conditions, meaning there's no mitochondria involved in terms of being able to have oxidation happens. And so you could think about red blood cells, which we know lacks mitochondria, and realize that they also will be producing lactate. And that is illustrated here, where red blood cells produce lactate. That lactate could then go on to be utilized in the liver in the process known as gluconeogenesis. So I wanted you to think about that as well. So I believe that when you understand enzymes, you really understand biochemistry. The goal of Science DIBS is to drill those basic skills. And the main way I do that is through helping you to understand how enzymes work. If you would like to receive a question and answer set that tests your understanding of lactate dehydrogenase, please send an email to dibs.science@gmail.com. Once the email has been received, you will be sent a reply asking for your mailing address. Each question and answer set includes 5 questions written on the outside of each envelope, and the answers are inside of each individual envelope. The goal is to have you answer the questions on your own before opening up each individual answer in the envelope. This will really test your knowledge. All question answer set envelopes are mailed to you in a bigger envelope. Please allow 3 to 5 business days to receive once you have placed your order. Question and answer sets cost $5.99 plus tax. If you still need the rationales for the answers after you open up the envelope and see the answers, please send an email to dibs.science@gmail.com. In the subject line for your request for the rationales, please include the number. There will be a number sign plus a letter number combo. Include that as written and put that in the email. After you do that, an email with the rationales will be sent to you. Thank you for supporting Science DIBS, where drills increase basic skills. I look forward to you all learning as much as you need to know about biochemistry.